everyone, welcome to EDUSOFT. Today is our sixth session. Before this, we have completed till fifth session. Please do watch for better understanding. In this session, we are going to cover arithmetic operations on NumPy arrays. So the basic question that arises is can we perform simple arithmetic operations on NumPy arrays? Yes, we can perform many arithmetic operations on NumPy arrays like product, rounding, decimals, LCM, GCD, trigonometric operations, set operations, unary operations, mean, median, and mode, standard deviation, and variance. So you can find the product of all the elements of your array. You can find the LCM, that is least common multiple. You can find the GCD, that is greatest common denominator. You can also find many trigonometric functions. You can perform set operations. You can also perform unary operations. Within unary operations, you can find the minimum value. You can find the maximum value. You can find the sum of all the elements of your array. You can also find mean and median, standard deviation, and variance. So coming to our first function, that is the product. We can find the product of all the elements in an array by using the prod function. So this is your one-dimensional array having elements like 1, 2, 3, 4, 5. So if you find the product of all the elements of this array, it will be in the form 1 into 2 into 3 into 4 into 5. So your output will be 120. So in this way, you can find the product of all the elements of your array. Our second function is rounding decimals. This function increments the preceding digit by 1 if the next digit is greater than or equal to 5. Consider this a equal to np dot array. Within this, you can find elements like 3.226, 5.67. Array equal to np dot around. So this is your syntax to round the decimal points. np dot around. Within this, your first argument goes the name of the array and your second argument is the decimal point. What it will do? It will evenly round to the given number of decimals, and in this array, for this array, what will be your output? Your output will be 3.23, 5.67. In this way, you can round the decimal points of the elements of your array. Coming to next function, that is LCM and GCD. We can find the smallest common multiple, or we can say the least common multiple, and the greatest common denominator. You can see your array as a equal to np dot array 3, 4, 6. These are the elements. X equal to np dot LCM dot reduce. So this is the syntax to find the LCM of the elements of your array. np.lcm.reduce. Within this, what you have to give as an argument, you have to give the name of your array as an argument, and you can find your output as 12. So this 12 is the LCM of 3, 4, 6. In this way, you can find the least common multiple of all the elements of your array. Another one is greatest common denominator. We can also call this as HCF, yani highest common factor. So this is your array a equal to np dot array 4, 8, and 52. So you can see your output is 4. This is the greatest common denominator, or say highest common factor of the elements 4, 8, 52 of your array. Coming to next operations, that is set operation. A set is the collection of unique elements. We can create a set array by using unique function. So what is the set? A set is the collection of unique elements. Unique elements का क्या मतलब हुआ? It will not be having any duplicate elements in it. So a set array is created by using what function? It will be created by using unique function. A set array is always a 1D array. So your set array will always be a one-dimensional array, and you can perform different operations like union operations over your set array, and you can also perform intersection operation over your set array. So set array, it can be created by using unique method. You can see over here, A is your ND array or NumPy array, that is equal to np.array 224489104545 8. So these are the elements, and you can see this array, that is A, is having the duplicate number of elements also. Now to create a set array, what you have to give as a syntax, you have to give b equal to np.unique. Within this, as an argument, what you have to give the name of the ND array as an argument. What it will do, it will find the unique elements of an array and will create the set array from these unique elements. You can see over here, b equal to np.unique a, print b, and you can see the array, that is the set array as 2, 4, 8, 9, 10 and 45. So in this way, you can create the set array by using the unique method or unique function. Coming to another operations, that is unary operations. So within unary operations, what you can do, you can find the maximum value, minimum value, and the sum of all the elements of your array. So to find the maximum value, what you have to give as the syntax, you have to give np.max as a syntax, and what it will do, it will return the maximum of an array or maximum along an axis. In this way, you can also find the minimum value. What you have to give as a syntax, np.minimum. Within argument, what you have to give the name of your array. What it will do, it will return the minimum of an array or minimum along an axis. Another thing, what you can also find, the sum of the elements of your array. What you have to give as a syntax, d equal to np.sum. What it will do, it will find the sum of array elements over a given axis. And you can see the output as this. So A is your array, that is np.array having elements like 2, 4, 88, 10, 40, 70 and 1. B equal to np.max, max value क्या है 88, output क्या आएगा 88. C equal to np.minimum, minimum value क्या है 1, output क्या आएगा 1. D equal to np.sum, so it will give the sum of all the elements of your array, that is 215. So in this way, you can perform different unary operations over your NumPy arrays. Coming to next is the mean, median and mode. So you can find the mean value. What is the mean? The average value of all the elements in a given array. A equal to np.array, this is your array. B equal to np.mean. So this is the syntax to find the mean value, and your output will be 26.25. What it will do, it will compute the arithmetic mean along the specified axis. Next, what you can do, you can find the median value. Median क्या होता है? It is the midpoint value after the array has been sorted. So here you can see C equal to np.median, and your output will be 9. What it will do, it will compute the mid value along the specified axis. Another thing, what you can also do, you can also find the standard deviation and variance. Let's find the variance of your array, that is A. B equal to np.std. So this is the syntax to find the standard deviation. Within argument, you have to give the name of your array. And in this case, your output will be 2.828. So this is the standard deviation of your array A. And it will compute the standard deviation along the specified axis. Another thing, what we can also find is variance. So here you can see C equal to np.var within bracket A. So this is the syntax to find the variance, and your output will be 8.0. What this function will do, it will compute the variance along the specified axis. Now coming to Jupyter Notebook, there we can see all the functions we have seen till now. So the first function which we are going to see is the product function. उसके लिए what we have to do, first of all, we have to import NumPy. I am going to import NumPy as NP. Then what we have to do, we have to create an array. Let's create it. A1 equal to NP dot array. Within array, what I want as an elements, I want my elements as 10, 20, then 2, 1, 5. Now I am going to use the product function. तो जो product function होता है उसका क्या role होता है? It will give the product of all the elements of your array. तो आपका array क्या है? A1. A1 के जो elements हैं 10, 20, 2, 1 and 5. So the product function will give the product of all the elements 10, 20, 2, 1 and 5. So for that, let's create another array. A2 equal to np dot product function का syntax क्या रहता है? np dot prod. Within argument in the product function, what we have to give? We have to give the array A1. After that, what I want to print the product of A1. So let's see the output and your output will be 2000. तो जो ये आउटपुट आपका आया है 2000, ये क्या है? ये जो आपका एरे है A1 उसके अंदर जो भी एलिमेंट्स हैं 10, 20, 2, 1 एंड 5 इसका क्या है? प्रोडक्ट है. कमिंग टू अनदर फंक्शन दैट इज द राउंड अराउंड फंक्शन. सो इसमें क्या होता है? इट इज यूज्ड फॉर राउंडिंग द डेसिमल पॉइंट्स. सो फर्स्ट ऑफ ऑल लेट्स क्रिएट अनदर एरे दैट इज A1 np dot array. Within this, what elements I want to have? I want to have 3.226 comma I want 1 या 5.16. Now I want to round off the decimals of these elements. So let's create another array that is A2 np dot. What function I'm going to use over here? I'm going to use around function. So उसका syntax क्या होता है? np dot around. Within this, as an argument, what is the first argument you have to give? The first argument is to be the name of the array, that is A1. And what will be the second argument? The second argument will be the decimal points, till where you want your array elements to have the decimals. तो मैं क्या चाहती हूँ कि जो मेरा array है A1 उसके अंदर जो elements हैं उनका decimal point कितना रहे? 2 decimal point तक वो elements मुझे show हो. So as the second argument, what I want to give? I want to give as 2. Now what I want to print that array that is A2. Let's see the output and you can see your output as 3.23 as the first element and 5.16 as the second element. Let's come to another function that is the LCM. Now, what if I want to find the LCM of the elements of my array? So, what syntax or what function we have to use? We have to use LCM dot reduce function. For that, let's create another array that is A. Now, np dot array. This is the syntax to create the NumPy array. As an element, what I want as 4, 8, 12. Now, I want to get the LCM of these elements, 4, 8 and 12. So, for that, let's create another array, np dot. Now, what I have to use? I have to use LCM dot reduce to get the LCM. Now, LCM dot reduce. As an argument, what we have to pass? As an argument, we have to pass the array जिसके elements का we want to have the LCM. After that, what I want to print this array that is B. Let's see the output and you get the output as 24. तो जो ये आपका output 24 आया है, ये क्या है? ये जो आपका elements हैं 4, 8 and 12 इनका LCM है. So in this way you can find the LCM. You can also find the GCD, that is the greatest common denominator, or what we can say HCF, that is the highest common factor. For that, let's create another array that is C. So np dot GCD dot reduce within bracket as an argument A. Now what I want to print that also. So print C. Let's see the output. And you can see output as 4. जो आपका GCD है यानी HCF है हाईएस्ट कॉमन फैक्टर उसका आउटपुट कितना आया है 4, और जो आपका एलसीएम है यानी लीस्ट कॉमन मल्टीपल, उसका क्या आउटपुट आया है 24. So in this way you can find the LCM and GCD of the elements of your array. Now coming to another function, that is the set operations. What if I have an array and I want to get the set array? So to create the set array, what function you have to use? You have to use unique function. Suppose this is my array, np.array, having elements like 1, 2, 5, 6, 2, 1, 10, 8, 8. So you can see in this array, that is A1, you have the elements 1, 2, 5, 6 to 1, 10, 8, 8. So you can see you have duplicate elements here. जो 1 है वो भी 2 बार आया है, 2 जो आपका एलिमेंट है वो भी 2 बार आया है, एंड 8 जो आपका एलिमेंट है वो भी 2 बार आया है. So in array you can have duplicate elements, but if you want to create the set array, तो set array क्या होता है? It will always be a one dimensional array and it does not have any duplicate elements. It has all the unique elements of your array. So let's create the set array. B equal to np dot unique. What function you have to use to create the set array? You have to use unique function to create the set array. Now I'm going to print my set array. Let's see the output, and you can see output as 1, 2, 5, 6, 8, 10. So what this function unique is doing, it will create the set array. It will take all the unique elements from your array, and from these unique elements, it will create a set array in the ascending, and all the elements are placed in the ascending order. You can see 1, 2, 5, 6, 8 and 10. तो जो आपके डुप्लीकेट एलिमेंट्स थे वो हट गए. यूनिक जो आपका फंक्शन है, इसने आपके एरे के यूनिक एलिमेंट्स लिए और उससे इसने क्या बनाया? एक सेट एरे. Coming to some another functions, that is the minimum, maximum, sum, mean, median, mode, standard variation and variance. So what if I want to find the maximum of A, yani maximum of all the elements of A? So let's create another array, that is C np dot max and with an argument A. Now I want to print that my maximum value. So write print within bracket, you have to give C and you can see your output as 10. तो जो आपका array है A, उसमें elements का आपका जो maximum value है वो कितना है? 10. In this way you can find the maximum value. You can also find the minimum value. np dot minimum A, and let's print that minimum value, that is D, and you can see your output is 1. So array A has the minimum value 1 in it. In this way you can also find the sum of all the values, yani the sum of all the elements of your array. So E equal to np dot sum of A. Now let's print the sum value, that is E, and you can see your output as 43. So 43 is the sum of all the elements of the array A. In this way you can find the maximum, minimum and the sum value. What if I want to find the mean, median and standard deviation and variance of my array? So let's find out. Array 1 equal to, what if I want to find the mean first of all? So np dot mean, and I want to find the mean of array A. Now I am going to print that mean, that is array 1. You can see output as 4.77 until 8. So this is the mean of your array A. Now what if I want to find the median? For that, array 2 equal to np dot median, and I want to find the median of array A. Now I want to print that median as array 2. Let's see the output, and you can see output as 5 over here. So 5 is the median of your array A. In this way you can also find the standard deviation. Array 3 equal to np dot std, and array name क्या है? A. Now let's print our standard deviation, that is array 3, and you can see output as 3.224137. So 3.224137 is the standard deviation of array A. Another, what you can also find the variance as np.var within bracket A. Now I'm going to print my variance, that is array 4, and you can see output as 10.3950. So this is the variance of the array A. So in this way, you can operate many mathematical functions, like you can find the maximum, minimum, LCM, GCD, product. You can find standard deviation, variance. You can find mean value. You can find the median value. So these are the different mathematical operations that you can operate on the ND array, or you can say NumPy array. Our NumPy series is completed here. We have completed 6th session in NumPy series. If you have any doubt in any session, you can ask me. Thank you so much. Please don't forget to like and subscribe.